What if you could work with some of the world's most innovative companies, all from the comfort of a remote workplace? Andela has matched thousands of technologists across the globe to their next career adventure. We're empowering new talent worldwide, from Sao Paulo to Egypt and Lagos to Warsaw. Now, the future of work is yours to create. Anytime, anywhere, the world is at your fingertips. This is Andela.
Hey friends, my name is Joe Karlsson, and this is a gentle introduction to building data-intensive applications. So, first of all, do you know how much data is created every day in 2022? Well, it looks like about 80 zettabytes of data. And by 2025, we're looking at about 175 zettabytes. That's over double the amount of current data we're processing today in just, 3 years? 3 years from now. That's coming up fast, right? So I want to talk to you about what it takes to build a data-intensive application, because knowing how to do this is going to be critical for building applications that can scale in the future. And it's hard, right? But wet your palate a little bit. I want to show you today how building data-intensive applications is a little bit like SpongeBob SquarePants. And yes, I'm serious, and we're about to dig in, right? SpongeBob is a reliable friend. He can absorb things like a sponge and scale to huge sizes. He's able to withstand nautical nonsense, even as our servers and users flop like a fish. And most importantly, he can be simple, right? So let's dig in to see how SpongeBob can help us learn how to build data-intensive applications. So, my name is Joe Karlsson. I work for a company called SingleStore, and I make a lot of TikToks and Twitters. So if you like what you see today, be sure to check that out. You can go to joekarlsson.dev/links for everything discussed here in this talk today, as well as all my socials. So go check that out. Okay, so before we begin, I'll be checking out the chat if anyone has any questions. And credit to Martin Kleppman for pioneering a lot of this content in his book, Designing Data-Intensive Applications, which you should totally go check out. A lot of this is from his content. Today, we're going to be introducing concepts about data-intensive applications and how you can get started building them. And this is for developers who are maybe have some comfortability with building some simple applications and are looking to scale up. Any knowledge about SQL or RDBMS is also really useful too. Okay, so we're going to be discussing what data-intensive applications are. Then we'll be going into the fundamentals of how to design and build a scalable data-intensive application. Three key tenets are reliability, scalability, and maintainability. And then, I know this isn't live, so I'm not going to do a Q&A today, but let's get started with our intro content. Clearly, we live in a world of data-intensive applications. And if we're not currently, it's going to be taking up more and more sectors very soon. So you may be asking yourself, what exactly is a data-intensive application? And in my humble opinion, it is an application that has one of these 5 core tenets. It has an application that has a mass amount of data, or where data is streaming in really quickly, where low latency queries on your database is critical. If you have a complex series of databases with joins or whatever, or if you have a massive parallelism or concurrency in your application. The bottom line is, though, that data-intensive applications is where data is the main constraint or bottleneck. I think previously CPU cycles was one of the main constraints, but in my humble opinion, with the advent of the cloud, that made that really less of an issue, right? We could, with a Kubernetes cluster or whatever in the cloud, we can just start scaling up servers and new nodes to start handling our applications. And in my opinion, as developers, one of the things that we're going to be struggling with the most is designing applications to scale up with their data intensity, not with the compute cycles, which is why this is important. So anyway, glad to be here. So obviously businesses are becoming more and more data intensive. We're seeing massively rising complexity and data analysis and data science, machine learning models consuming massive amounts of data in real time, and users who are becoming more, requiring that as their applications scale. They want their we want the apps we use to be fast. We want them to be in real time. We want those real time alerts. Being able to wait 24 hours for a batch processing job no longer cuts it. And our applications are struggling to keep up, and for good reason. Like, building these apps is hard. It takes time and it takes experimentation, and it usually involves hybrid approaches in order to scale our applications up. That's okay. That's okay. I like giving some more concrete examples here, and I've broken these up by industries and verticals and some use cases for each of them. This is just a small example of what's available for data-intensive applications here. Dashboards, real-time ML, streaming, ads, optimization, real-time, recommendations, IoT devices streaming in mass amounts of data into databases, real-time data, dashboards, whatever. There's so many things you can possibly do. And again, this is just a small smattering. Okay, so I'm obviously biased here, but SingleStore is the single database for data-intensive applications, and I'm going to tell you why today. SingleStore handles this and makes it easier to build these applications because they can get incredibly difficult. And when you need a database that's going to help you solve those problems as easily as possible, we're going to try to keep our architecture as simple as possible, and SingleStore can help you do that. So if you're going to take anything home today, just know SingleStore is the best database for handling data-intensive applications. We have some comparisons here too. We scale better, we're faster, we have the lowest latencies, and we handle the most data models and most parallelism than any other database. So go check those out. We're great for data analytics, real-time machine learning, real-time recommendations, whatever. We handle all those amazingly well. So, okay, let's jump into it. What does an architecture for a data-intensive application look like? Again, great question, dear listener. They tend to be pretty complicated. You have lots of different database pieces kind of fitting together, shuffling, transforming, and saving data in lots of places as they flow through. We're seeing a lot of microservices kind of decoupling databases, which is fine, but it does make our applications more complicated. Which, I don't know about you, I hate. I think developers have a tendency to overcomplicate things to appear smarter. We are handling harder problems, and I think we're kind of in this age of trying to understand and simplify these things as we scale. I think Kubernetes is an example of something that's going through that right now and getting easier and better to use as it matures. But data-intensive architectures and databases just aren't quite there yet. Again, SingleStore does make that a lot easier. We simplify that by handling more data types and better performant than alternatives. Lots of users are coming and using us to replace lots of different aspects of their data-intensive application because it can handle that scale and simplifies their architecture. Okay, much, much better stripping it all down, right? Thank you, SpongeBob. All right, so let's get into the nuts and bolts of designing a data-intensive application. So the three big ideas here today are reliability, scalability, and maintainability. These are the three things that make up a scalable, data-intensive application. Let's dig into all three of them and kind of explore each one with some real-world examples. First up, reliability. We got our SpongeBob with this good old reliable friend, Patrick Star, right? Best buddies, there to the end, through thick and thin, just like our applications and our databases supporting those applications, right? So typically, as developers building a data-intensive application, we're expecting them to perform as expected Duh. We want them to be able to tolerate any errors that a user might make. Okay, yep. Good luck predicting those. We want it to be fast performance, and we want it to prevent any abuse or insecurities or any leaking of any data or whatever, right? We don't want any user secrets kind of getting out into the ether. This all seems pretty straightforward, right? But it gets complicated actually trying to make sure all these things actually happen that we want, right? So first thing with reliability is hardware and software faults. So that means a lot of times, especially for databases, redundancy was really difficult, even frowned upon in a lot of situations. You see a lot of single node databases popping up, but we're moving towards a future of systems that tolerate more losses of the machines, right? And we need that to include our databases too. Netflix, for example, has a tool called Chaos Monkey that randomly shuts down servers and databases to ensure that other systems are still working and it's backing up, which is really helpful for their scalable architectures. But you also have software architectures too. It's unlikely, again, not impossible, you want to plan for it, but that large numbers of hardware components fail at the same time. Typically, it's software or human errors related to software that is the main component of something shutting down. And having redundancy helps us, and some other stuff we'll talk about in a little bit, like testing and good systems and safeguards does help that as well. SingleStore, for example, has data copied horizontally on leaf nodes in order to improve redundancy. So each leaf is replicated, its data, so that if one of the nodes goes down, you don't lose your data. You don't have any downtime. It re-elects a new leaf node so that you don't lose any of that data. It stays online in case something goes down. All of the data is replicated across all of the leaf partitions, and your data is still there. You can control how many leaf nodes it's replicated to and the amount of data, or like what kind of write or read consistency you want, so that it will, you get the performance hits you want. So human errors, humans tend to be the least reliable component of any system. It's true, right? Computers go down, but humans go down way more often. Configuration errors, outages, whatever. Humans are the leading cause of outages. That's just the way it is, right? So as developers, we want to design systems that minimize the opportunities for human error in our systems. That means we want to have interfaces and admin interfaces that are designed well so you don't make mistakes, or that you can't do things that you don't want other people shouldn't be doing on your system. Automated testing can be really helpful for this, and deploying fully featured sandbox environments locally or in the cloud to do testing on could be another way to help mitigate some of these issues. This is a minor sidebar, but databases frequently get left out of the DevOps discussion. And I get it, it's hard to do, but that doesn't mean, data tends to be the most important and critical part of our application, and leaving it down to a manual process is going to leave you vulnerable to human error being introduced to your data-intensive application. Okay, great. TLDR, just have good practices to protect your system from bust-down humans. And scalability. This is how we cope with increased load. So we need to be able to scale the system up in order to handle. So this is the second tenet, right? Scalability, to handle the increased load of our systems, right? Whether that's increased throughput to our database, we're adding more parallelized users kind of accessing data, or whatever, right? And I want to use an example here to illustrate what I mean by scalability. So let's talk about Twitter, right? The core tenets of Twitter: we want to post a tweet, and we want each of our users to read tweets from a timeline. So there's two key methods you could use to implement this. We have the two posting tweets. We're seeing about 4,000 to 12,000 tweets posted per second, about 300,000 tweets per second. This may be different. This was a couple of years ago I got this data from, but you get the point, right? We want to design the system. So the first way you might be able to do that is by building a couple tables. We have a user who has a follows table, and then we have a users table that allows us to find all of the users that are tweeting, and we can pull that into a feed, right? We could do a couple joins and pull that in. But we find Twitter actually did this, right? And if you were going to build this at home, like your little toy Twitter app at home, which by the way, that was my first web app I ever built, just to learn web development, little Twitter clone. But with this approach, the system struggled to keep up the load of the home timeline queries. That's because joins are both expensive with memory and time. Doing all those joins within the system was really, really expensive and slow. And as the users went up, right, we posting more and more and more, and they're reading more and more and more, those joins became a major blocker for the system. Yes. So that didn't work. So what's the second method that Twitter used? This is a fan out approach. So think of it as like a mailbox, right? So like a user posts a tweet and they put it in their mailbox, and then we do a fan out. So then a service reads that letter in your mailbox, and it copies it and it sends it out to a bunch of other people's mailboxes out. So every user that follows you gets it in their timeline, which allows you to do way less joins. And you're just inserting them into each new timeline cache. There's a bunch of benefits of this, but there is one downside. The downside of this approach is that posting a tweet now requires a lot of extra work. Some users might have like 30 million followers, like a Justin Bieber or Kim Kardashian or something, right? So that means that a single tweet from one of these power users would result in over 30 million writes to other mailboxes, which is a lot, right? This approach does work really well, but there are some downsides to it, right? And it's a lot more complicated, especially when you're talking Twitter scale. So what did Twitter do? They actually approached this using both. So they used a hybrid approach. Tweets continue to be fanned out among most users, but for a small number of power users, they still use this first method to kind of send them out as read only. So people would go and read the message from the person they're following, which is wild. It's a little bit of both. I think that's kind of genius though. And that tends to be the approach with a lot of these systems, right? You kind of like see what happens, you try to approach it, and you have to try to do some interesting massaging to get it to fit your system. So, okay, there we go. By the way, SingleStore also does this too. We do a horizontally scalable database to try to increase parallelism and concurrency, which increases throughput for our databases. But there's lots of ways you can do it. You can scale out horizontally, like SingleStore does. Scale it vertically, which typical SQL databases do. I know you can do it with a lot of other ones, but like that's just buying a bigger server to handle the increased load. Yeah, those are kind of the systems that do it. In my humble opinion, going the node-based horizontal approach is one of the most scalable and effective ways moving forward. Okay, last core tenet here is maintainability. So the majority of our software cost is actually not from the development of the initial product, it's the ongoing maintenance. Us engineers are very expensive, and it's important for us to build systems that are maintainable long-term. So that means that there's three things we need to keep in mind for this: operability, simplicity, and evolvability of our systems. So operability does not refer to performing operations or surgery. Operations has to do with the team that's responsible for the ongoing operations of the code base that's running. So tracking down problems with the infrastructure or software. They're anticipating future problems or scalable problems. They're monitoring for anything that goes down or any sort of systems. They're performing complex maintenance tasks and security audits of the system. Bunch of these things. Basically, good operability means you're making routine tasks easy for your scalable system. Okay, simplicity. This allows us to manage complexity and make it easier. Obviously, building complex systems is really, really hard. And the more moving parts you have in a system, the harder it is to troubleshoot and build. Thinking long-term about your product, you want to make sure that it's easy enough for new people to come in and start using it. I've seen that a lot too. I feel like engineers, we get really into something, we go crazy about it, and we realize it's hard to maintain. I know personally for me, I've favored low maintenance, scalable solutions, because I would rather be building new stuff than maintaining stuff long term. And by focusing on simplifying our architecture, that allows us to do that. Again, I'm going to say this just last time here, but about SingleStore, it's people are replacing lots of different their databases because it's much more simple and scalable to do that. If you have 3 different databases, like in-memory database, a NoSQL database, and a SQL database like Postgres or whatever, if you can simplify those down into one data service that does all those things, that's going to make your ongoing maintenance so much more simple. SingleStore can do that, which is amazing. Check it out. And lastly, evolvability. The only thing that's certain in software is change. The only certainty is change, something like that, right? But we want to make sure your systems are built to evolve and change, which I will say, data makes that hard. Data is sticky. And we want to make sure you're trying your best. You can't predict everything that's going to happen, but you can try your best to make it easy for you to change in the future as new requirements come up in your system. Okay, so quick recap here. If you're building out a scalable data-intensive application, you need a database and system that scales with your usage as it grows. Your data usage will grow. That's just how it goes. Data is sticky, and it's unless you have like a strong governance policy, it's probably going to be staying there and growing. So you want to make sure your system can grow for at least the next 5 years. Honestly, you need to make sure you're securing your data, and you can ensure privacy for your users. You need to make sure you can handle the load today, as well as your anticipated load again within 5 years, which is hard to predict. It needs to be capable of delivering analytics. I would recommend making sure it can handle real-time analytics, because that's going to be, if it's not a current need, you should be anticipating it as a potential future need for your system. You want to make sure that there's no noticeable lag, especially for the end users of your system. This is all admittedly a tall order, but SingleStore can do all this and way, way more. It's a fast unified database system that's ACID compliant, all that good stuff. But you should definitely go check that out. Okay, so questions, I'm in the comments if anyone wants to chat. Otherwise, next step, I would recommend you checking out Designing Data-Intensive Applications by Martin Kleppman. I also recommend setting up your own project. I think the best way to learn something is to build it yourself. I have some examples that I can share in the chat here. Building your own, stock ticker, stock scraper. You could do a real-time Twitter data stream in and doing analysis on that with machine learning models. There's tons of huge data sets you can play around with. The best way to do that is to find someone a system that is free with like a developer tier and try to build something. And I think Go is a great place to do that too. In fact, I've got a great shipping logistics demo I'm going to share in the comments here. Definitely learn by reading. There's a bunch of ways to do that here. And if you want to get started with SingleStore and try that out, it's a great, free, easy way to do that. We have a managed service. You get $500 in free credits today. No credit card needed. Just so you can go try it out. It's amazing. Go to singlestore.com/managed service trial. Okay. And here is some additional reading if you want it as well too. I'm going to flash this up. Great. And thank you so much, everybody. This has been an absolute blast. I am so honored to be here. Y'all are amazing. Again, my name is Joe Karlsson. I'm a software engineer and I work at SingleStore. If you want to follow me, check me out at JoeCarlsson1 on Twitter. That's in the lower right-hand corner. If you want to follow me on all the other links, you can check out joecarlsson.dev/links. All right, I'm a head out. Thank you so much. Talk to you later.